So today we're going to be writing exponential expressions from word problems. I want you to think about this situation. Beverly comes to school with a secret. During first period, she tells the secret to her one friend that she thinks she can trust. Her friend does not keep her word and tells other people. Each period, the number of people who know the secret will double. So we're going to model this in two ways. One is with a picture and one is with a table. So in our situation before school, the only person who knows the secret is Beverly. So there's one total person. During period 1, Beverly tells her friend. So now Beverly and her friend know the secret, so that's 2 total people. But every period it doubles. So by the end of period 2, 4 people know, and it doubles again. At the end of period 3, 8 people know, and finally, at the end of period 4, when it doubles again, a total of 16 people know. So now we're going to try to model this using our table. So before school, I'm going to call that period 0 because it's before school. And before school, the only person who knows the secret is Beverly. Beverly, during period 1, tells her good friend, so now we have 2 people who know the secret. And unfortunately, every period after that, it's going to double. So where we had 2 people, we double that, we get 4. And then at period 3, it's going to double again, which will give us 8. And finally, at the end of period 4, it'll double one last time, and 16 people will know. This is an example of an exponential expression. And what we're going to do is we're going to find out the formula that we use, or the format for writing exponential expressions. So this one here models the growth of Beverly's secret. I want you to think about what each of these numbers could stand for, because this is going to be a pattern we use when we're looking at these exponential expressions. So the 1 represents our starting value. That's how many people knew the secret at the start. Just 1, Beverly. The 2 represents our change factor. And our change factor tells us how the secret is changing. In this case, it's doubling, or times 2. And this T is our variable. It's going to stay a variable. And in this problem, it's representing time, or the number of periods that go through, that pass. Okay? You'll see this modeled in this format. A, B, X. A times B to the power of X. Our A is our starting value. Our B is our change factor. And as I said, our variable is going to stay a variable in these situations because we don't know how many or how much time has passed. If you can look at a word problem and identify your start value and your change factor, you can write these expressions. So let's look at 2 different word problems. Steph Curry posts a video of a puppy playing the piano, and he shares it with 4 friends. The video goes viral, and the number of shares increases by a factor of 10 every minute. Write an expression to model this situation. So the first thing we need to find is our starting value. And our starting value is that he shares it with 4 of his friends. So 4 is going to represent our starting value. Next, we need to find our change factor. So when we look at this, it says the number of shares increases by a factor of 10. That means our change factor is 10. So that's the next part of our expression. And finally, the last part, our variable, that's going to stay a variable, but in this case it represents every minute. So X will represent the number of minutes that pass. Okay, tomorrow we'll learn how to solve these types of exponential expressions, but for now we're just learning how to identify the parts from a word problem. Let's look at one more example here. Mount Rainier received 670 inches of snow during the last winter. Once the temperature warmed up, the amount of snow on the ground decreased by half every week. Write an exponential expression. So again, our starting amount, that's what we want to look for. It started with 670 inches of snow during the winter. So that is our starting value, 670 inches of snow. It decreased by half. Okay, so that's our change factor. The amount of snow decreased by half. You could see this written 2 different ways, okay? Decreasing by half, some people would write it as a fraction. A lot of people will write it as a decimal. So I'll put it both ways just so you can see it. So our starting amount was 670. It's decreasing by half. And then finally, we're looking for our amount of time. It's happening every week. Now remember, this stays a variable, but it's important to know that x represents the number of weeks that are passing. Okay? So that's how you write an exponential expression.